Hi and welcome to another 5-minute tutorial, and this time about subsurface scattering. I start with showing you the difference. So this is an image that I rendered without subsurface scattering. That means that all the rays are reflected directly on the surface. So my grapes right now look more like olives, but that is how good I can get it without using subsurface scattering. If I then add subsurface scattering, it now looks like grapes, because now the rays go beneath the surface and you get a brighter, more vivid image that resembles grapes a lot more. So with subsurface scattering, especially on organic stuff, you can really enhance the look when you let the rays go a little bit below the surface, as I have done here. So how does it work? Well, we can use our beloved Susan, and we use the normal principled BSDF, and here you can see we have subsurface, and everything between subsurface and specular belongs to subsurface. So first of all, we have the type of subsurface, and the random walk, that is the correct type. Everything will work perfectly, but subsurface also gives a lot of noise. So if you can't handle the noise, then you might use Christensen Burley, not so accurate, but gets less noise. And are you doing a character, then perhaps random walk in skin, because that is just for skin. So using random walk, and then we can use weight. No weight, no subsurface. When the weight is 1, then we have full subsurface. Normally it should be like 0 or 1. We can have it between here, but they normally recommend 0 or 1. After that we have the radius. The radius is how far each color should go. So red goes 1 unit in, and the green 0.2 unit in, and the blue 0.1 unit in this case. You can change them as you want to. How far is a combination of the scale and the radius. So it's just to multiply the scale with the radius to get the amount here. And so that means that you can adapt this depending on what type of object you have. And last we have anisotropy, and that is how it is scattered below the surface. So if you have a 0, then it's uniformly scattered, meaning that you have scattering on all the directions. If it's 1, then it's more like the ray just continues that amount of radius that you have put straight into the object without scattering or bending. So you can select what is good for you, depending as before on the type of object and material you want. But those are the parameters that you can play with. So if I increase the scale, you can see now that it gets more bright here and almost look like wax. And if I take too much, it's just a blur white. And if I take it to 0, it's nothing. So somewhere between would be great. Right now you can see that we also have stuff around the eyes here, and you might want to take away that. Then we can cheat a bit by using ambient occlusion. So if I press Shift A, input an ambient occlusion, and I press only local and inside, and take the AO to the surface, you can see now that the thin parts get then black, and the white parts, they are then, the bigger part, they get white. And then you can just take down the distance. So like say, take like this, and then you take away, as you can see, it gets darker here. That means that we then use less of the weight if I put it in like this. So by that, I can then remove this around the eyes here, using the ambient occlusion with inside to understand what is the thin part and what is the thick part in my subsurface scattering. So that is a little bit of a tip that you can use to get more or less weight if you have a hard time getting it correct. Okay, that was my 5 minutes, and hopefully I've learned something about subsurface scattering now, and I just say bye for now and see you tomorrow.